If you use autonomous AI agents to do complex work, you are effectively employing a temporary worker with no long-term memory. Every time they take a new step, they have to reread a massive, ever-growing mountain of past conversation history just to figure out what they are supposed to do next. As the worker tries to hold too much history, the structural stress on the system increases. This leads to hallucinations, contradictory plans offered with absolute confidence. This dynamic sentience map visualizes the AI's logic spine, claims, evidence, and constraints. When the path breaks under pressure, it triggers a contradiction node. It catches a stale memory trying to cross the boundary, stopping the disputed region and identifying failures that standard logs miss. When an AI model hits this state of decoherence, the only safe response is to fire it immediately. Usually, that means losing the entire agent. Terence White's architecture is designed to let you fire the brain while keeping the agent's history and permissions intact. Model B arrives as the replacement. It has zero context. Replaying the entire history that broke the first model will just lead back to the exact same structural failure. To fix this onboarding problem, the system uses the OpenLine half-life protocol. Half-life compresses the data chain into a dense causal state. The bulky original receipts move to a cold archive, keeping the working memory light. Before compression, an independent replay must prove this smaller memory produces the exact same decisions as the full history. Verified memory means the agent doesn't need to reread its entire life to take the next step. It cuts operational drag without losing the evidence. When Model B completes a task, it presents a cryptographic signature to prove its work. This handoff is intercepted by the OpenLine receipt gate. The gate ignores the digital envelope and scans the internal documents. It separates the sender's attestation from the receiver's appraisal. If the evidence is present, it issues a signed commit stamp. If it's missing, it issues a quarantine. Secure handoffs require the receiver's infrastructure to independently check what a record actually establishes for the next system. The workflow escalates. The model must now execute a permanent action, like spending capital or deploying code. Verified commit drops a protective layer over the destination tool. This mechanism forces the tool to verify a receiver-approved receipt, binding the request to a specific target and a one-use cryptographic code. The tool burns the permission slip after one use. A duplicate request is rejected because the code has visibly expired. Terence White's focus on structural limits comes from his Bay Area roots. The 1989 earthquake proved systems fail when they exceed their measurable load. His framework, coherence dynamics, applies that same math to AI, calculating the stress scalar to predict when logic will decohere. Because the memory and permissions are decoupled from the model provider, the user owns the continuous state. They can simply swap the brain tomorrow without losing the agent's progress. AI autonomy comes from owning the state and the permission boundary. The user owns the job. The model is just a temp.